Welcome back to Making Purple Gold. This is part 2. If you haven't seen part 1, I'll pin it in the comments. Let's get right into it.
The only sad part was that it was a complete piece of trash, and having to remelt it had apparently caused it to get really oxidized. This told me that I only had one real chance to pour it out, which wasn't ideal, but at least now, I knew exactly what to do. So, I quickly whipped up a new batch of the purple gold.
Looks like a marshmallow.
And this time, when I poured it out, I was really happy with what I saw.
Okay.
I then let it cool down to room temperature, and when I took a closer look at it, it was definitely the best result that I had so far.
It seems like a lot of these issues are just him learning just proper metal casting techniques. Now, I'm not an expert on metal casting. You mentioned speed being a component. I mean, certain ways you tilt or pour the device. I mean, I know he's doing all the right things with using the argon to prevent oxidation, as well as his use of borax, but there's probably a lot of intuitive knowledge there that you can read a procedure or a process on metal casting just like you can for starting up a reactor, and there's just a few things that come up that you'll just learn with experience over time. And it's really exciting to see someone who has a lot of, I would say, broad knowledge around chemistry and these sort of processes, but then he branches out into some of these like highly specified skills. It's really cool to see someone do that, and again, not afraid to show some of their missteps on camera. That's one of the many things I love about watching NileRed's videos.
I mean, it still wasn't perfect, but it looked way cleaner, and it
pretty
wasn't
good to me.
anything like the crusty mess that I had before. The only thing that I thought was odd was that it was silver, and I had assumed that without a lot of the oxides, that it would have been significantly more purple. At the same time, though,
Purple
I
in the
figured
center.
that maybe it was just a bit of aluminum or something that was on the surface, and that it would be really easy to get rid of.
Kind of reminds me of those little chocolates that you crack that are like brown on the outside and you have like the weird gooey stuff in the middle. Never been a big fan of those, but yeah, silver on the outside, maybe purple on the inside.
So I decided to try sanding it a bit, and I was assuming that when I flipped it over, I
Put
would
it on
see that
purple to
really
make it
nice
purple.
pinkish purple color, except it was still just silver. I then tried sanding it even more, thinking that maybe I just hadn't taken enough away, but it didn't seem to make a difference.
Maybe it's not purple on the inside.
When I saw this, I was honestly kind of confused, and the only explanation that I could think of was that I had somehow failed to make the purple gold. So to check this, I was going to have to break it open, and this time, I was even more surprised by how strong it was. I was hitting it way harder than before, and
Wow.
it didn't seem to do anything, and eventually, it ended up making a huge dent in my wooden table. After hitting it 7 times,
big
though,
nail.
I was finally able to crack a small piece off of it, and I was kind of upset by what I saw. This is because inside of it, it was definitely colored,
Muted
and it
purple.
made no sense why sanding it wasn't working. What I thought was even more upsetting, though, was that it was only
They're
barely
so small.
pink,
Yeah.
and it wasn't nearly as vibrant as the first attempt. This also really didn't make any sense to me, because I'd basically done the exact same thing as before, except without any air present, and it really shouldn't have had any effect on the color.
I'm not sure.
However, I was going to have to be absolutely sure that this wasn't an issue with the new setup, or with the different aluminum, and to test this, I just quickly did the exact same thing, and I made a fresh piece of it, and I waited for it to cool down.
Okay.
I then got my hammer, and this time I protected my table with a steel plate, and after one good hit, I was really happy with what I saw.
Okay.
It was actually purple, which told me that my setup and my aluminum were probably fine, and I still have no idea what went wrong with the
Just an anomalous piece you happen to use. That's fascinating. I mean, statistical anomaly, perhaps? Just like I kind of mentioned in the previous video, there's a chance if you fission uranium-235, you'll get a piece of gold. Very low. Should never realistically happen, but I guess this is also appears to be a larger piece, so when you have a larger, more of the material, you're less likely to have these sort of weird things to happen, but I don't know. Maybe someone in the comments does.
Either way, I then took one of these pieces, and I assumed that with the much stronger color, it would actually sand properly, but that apparently wasn't the case. Like before, no matter how much I sanded it, it never turned purple.
You should sand some of the pieces off, because if he's sanding off some of the purple bits, it might get lost in the purple sandpaper.
And I just couldn't understand why. What was even worse, though, was that after this, I tried just sanding the purple part itself, mostly out of desperation, and I was devastated when I saw that it turned silver.
There's not that much purple. I had no idea
how this was even possible, but it was a horrible thing to see, because if sanding it or grinding it wasn't an option, it would be extremely hard to make anything nice out of it.
Yeah.
As a completely last-ditch effort to fix this problem, I decided to drop this little piece of it into a beaker and to add some hydrochloric acid.
To separate it.
I thought that maybe just a very thin layer of aluminum was blocking the purple gold or something, and I was hoping that the acid would get rid of it. However, as the aluminum disappeared, it just slowly went back to being pure gold, which I actually thought was pretty interesting, but it didn't help me at all. At this point, I was really lost as to why this was happening, and I had almost no idea how to fix it, and I ended up spending the next few days trying a bunch of other random stuff.
That's cool, though. I guess you can use hydrochloric acid to go fully backwards and not only remove the aluminum and just remove the aluminum from the thing. Because that's about as close to before. I mean, it's kind of hard in processes to go completely reversible without, like, distorting it or whatever. Like, in the previous video, he ended up going from when he removed the gold and then ended up changing it back and ended up in kind of the gold, rocky, powdery stuff that you would see like some of the pioneers used when they were panning for gold back in the 1800s, but it's interesting to see he went back to this.
I then spent another few days reading everything that I could find online, and after finding absolutely nothing useful, I honestly kind of felt like giving up. Before doing that, though, I decided to look at the patent one last time, and this turned out to be a really good idea because I saw something that I'd somehow never noticed before. It was also almost just said in passing, but it was here where it was mentioning the purple color, and the key words were, at least on annealing, at 600C.
What's interesting is these sort of like procedural and process reviews. I mean, I know this is a patent, so this isn't exactly quite the same, but he's effectively using it as a procedure due to the absence of a procedure. These review processes have definitely different individuals look at it, and they're also separated somewhat by time for if you were to, say, act as a second reviewer after someone else. And that's mainly just because you notice things differently after, what I always call it, letting it get cold. Like after you read something or after you write something, if you try to review it too soon from it, you're probably not going to see anything that different. But if you were to let it get cold, have someone else look at it, or let a day pass or something, you're going to notice things you haven't seen before. And that's why a lot of major procedures, including ones for like starting up and shutting down a nuclear power plant, go through this rigorous sort of process. So you can absolutely accommodate everything. You'd also do it to incorporate lessons learned from earlier on, or maybe some previous condition reports, things that happened with equipment, whether it be something breaking or just something behaving in a bit of an unusual way. These things are captured, so you'll be ready the next time that happens. After, of course, fixing or making the necessary upgrades to correct the process. But there's a whole section in these procedures that talks about that's a historical record, if you will, of things that have gone wrong, so you can reference it when you're doing your pre-job briefing.
This didn't directly address the problem that I was having, but it implied that there was a way to enhance or recover the color, and I figured that this was my only chance.
Enhance or recover the color.
So I just quickly preheated an unused crucible to 600C, and for this attempt, I also made this fresh new piece that I had sanded down nice and flat. Just like all the other times, this made it completely silver, and it kind of just looked like a generic piece of metal.
Just shiny aluminum.
And I had a hard time believing that this could actually turn purple. There was only one way to find out, though, so I dropped it into the crucible, and then based on absolutely nothing, I decided to leave it for about 30 minutes. When I came back to it, I was honestly feeling pretty hopeful, and I was really curious to see how it was doing. So to get a closer look at it, I just carefully pulled out the crucible, and I dumped it onto some insulation, and I was genuinely shocked by what I saw. Almost like magic, it had actually somehow turned
Almost kind of looks
purple,
like an opal.
and the moment that I saw this, I was really relieved.
Huh.
This is because it was very obvious that the heat treatment had worked, and the project was thankfully no longer at a complete dead end.
Changes color
What I
under
thought was
heat.
really interesting, though, was that as it continued cooling down,
Ooh, okay.
the color of it slowly changed, and it was gradually shifting more towards that pinkish purple. However, it didn't seem to get quite as pink as I saw with the first attempt, and when I took a closer look at it, it appeared to be a darker purple. I mean, it still definitely wasn't as purple as the stuff that I saw online, but this at least showed me that even with the same recipe, the color could actually be pretty different. This also made me think that
Just your
maybe by
individual
annealing
piece
it
of it.
for longer, or just in a different way, it might have been possible to make it even more purple. With all that being said, though, right now, what I had was still kind of a piece of crap, and I felt that the most important thing to do next
It's learning.
was to see if it was even possible to make something nice. More specifically, I had to see if I could actually
Can you
mold
mold
it
it?
into a specific shape
Quest
and then
progress.
clean it up, and I was really tempted to just immediately try and make a ring. However,
going
I
straight
knew
for
that
a
starting
ring.
with something complicated like a ring would be a horrible idea, and it would introduce a whole bunch of new
Not
issues.
a jewelry person, so
instead,
that sounds like
I
a
decided
hard,
to just make a
difficult to
simple little
spike.
bar. In particular, though, I really wanted to make one that looked exactly like a typical gold bar, except that it was purple, and I went ahead and melted a bunch more metal. After that, I went and got one of my small bar molds, and this time, I was gonna blast it until it was red hot. I was really hoping that this would prevent the metal from freezing and help it fill the mold better, and when I felt that I was ready, I carefully poured it in. I was a bit concerned that I was going to miss or something, but it all turned out fine, and I was really happy to see that it easily filled the entire mold. I then let it all slowly cool down.
Yeah, what he did preheating both the cast and the tools that he used to grip it makes a lot of sense, just in terms of not losing that heat quickly. That's that part I can understand.
And when it was eventually around room temperature, I had to get it out of the mold, and I was a bit worried that it might be stuck. However, that clearly wasn't the case, and it just easily fell out, and this made it pretty clear to me that there was no issue with molding it.
Nice.
There was, of course, still one problem, though, and that was how ugly it was, and what I had to do next was see if I could actually turn it into something nice. To do this, I decided
on
to
to
just
step
sand
three.
it by hand, which wasn't exactly ideal, but I didn't want to lose any of the precious gold dust.
Get all that.
Unsurprisingly,
Like that he's using
though,
gloves.
this turned out to be super tedious and difficult, and it ended up taking 10 hours to get it
Whoa.
into a shape that I liked. I then polished it by moving up to finer and finer sandpapers, and when I eventually felt that it looked good, I annealed it, and this was the final result.
Wow.
It was pretty much exactly what I was
That's
hoping
beautiful.
for, and it was just like a normal gold bar, except it was pinkish purple.
Just a purple little gold
and I was
bar.
really happy with how it turned out.
One of the other fascinating things about gold, so I mentioned in part 1 that it could be used as a diagnostic aid for cancer, but it can actually be used to treat cancer. It's used in brachytherapy, which is close range cancer treatment that involves placing radioactive sources either inside of it or right next to the tumor. So for things like prostate cancer, for instance, where you have a fairly accessible point of entry. And you can either use radioactive gold, gold 198, or you can alloy it with a different isotope such as iodine 125 or palladium 103 to perform these little radioactive pellets or seeds, I've heard them referred to. Then you implant them near the tumor, and the gold casing, because of the density of gold, in the case of whether you're using pure gold or gold with palladium, will just ensure it's a very localized, concentrated dose. Because your objective is to use a radioactive source to kill cells, but you just want to harm the cancer cells. You don't want to damage the surrounding healthy tissue. And gold is very good for that. One thing is gold is well tolerated by the body. It's not a toxic element like using, say, plutonium, which is just a toxic heavy element like lead. It's very precise because you can have these very small targets. These small seeds can just affect a very small area, but can be quite deadly, which again, you want to kill the cancer cells. And it's also easily manipulated. It can play well with a lot of different radioisotopes. So it can be customized to what the patient needs depending on what type of cancer there is, how aggressive it is. You can dial your setting a little more precisely just by combining it with different radioisotopes to treat the cancer precisely. It's interesting because before I became a nuclear engineer, I didn't realize gold could be used as medicine.
The only thing that I thought was odd was that it didn't seem nearly as purple as my other piece, and this one kind of looked like it was a light pink. However, after a bunch of testing,
pretty.
I found that this was mostly just because it was way shinier, which made it appear a lot brighter, and I'll talk more about this later on. With all that being said, though, being able to make this fully proved to me that it was definitely possible to cast and clean up the purple gold, and at this point, I was feeling pretty excited.
What's also fascinating is, since you already mentioned you did extensive research and there's not a whole lot of stuff out there that can help you as a procedure, NileRed's given people a process to work with that is better than just, reading and following the patent, because he's had a few things to fall back on. So this is pretty cool. And this is on YouTube for free. Awesome.
However, my mood completely changed when I decided to take a much closer look at it, and I was kind of horrified by what I saw.
Oh, it's got little holes.
It was apparently riddled with a bunch of small cracks, and I have no idea how I didn't see this at all up until now, and I think I was just blinded by all of the excitement.
Or maybe they slowly came in.
What made things even worse was that it also looked like the color wasn't very uniform, and there were a lot of spots that appeared to be completely colorless, almost like the metals didn't mix properly.
So probably wouldn't want this as a wedding ring, because you tend to ding it when just through doing stuff with your hands.
In my opinion, though, that would be a relatively easy fix, and I just had to mix things better, and the much bigger problem was all of the cracks. This is especially because once I noticed them, I couldn't just unsee them, and I couldn't help but think that they were super ugly. What made it even more horrible was that it was throughout the entire thing, which meant that I couldn't just sand it away, and when I looked back at some other random pieces that I made, I noticed that it was there too. At first, I tried to convince myself that maybe that was just how purple gold was, and to prove this,
the aluminum.
I ended up buying a small pendant from Li Hua. The moment that I opened the box, though, I immediately realized that I was just in denial. This because the surface of it looked almost perfect, and I wasn't able to see any of those gross cracks in it. It was only when I really zoomed in that I could actually see some small surface defects, and there were definitely at least a few small holes. I could also vaguely see that, like mine, the color wasn't perfectly uniform either, but overall, it was clearly way better than what I made. As a quick side note,
good to know. That's actually one thing that I'm surprised you didn't show earlier in this video, but yes, getting a picture of, what the target is, just so you know what the finish line looks like, and if you could even improve on it one way or the other.
It also seemed to be significantly more purple than my pinkish bar, but again, this turned out to be mostly just a lighting thing, and I promise that I'll talk about this more later on. But anyway, at this point, it was pretty obvious that these holes weren't meant to be there, and the very unfortunate part was that I still had no idea what I was doing wrong. All I knew was that I hated how ugly it was, and that this was unfortunately something else that I was going to have to fix, and this project really just felt like a never-ending sequence of problems. With that being said, just like before, I ended up trying a bunch of random things, and when they all inevitably failed, I desperately looked at the patent, and I tried searching online. However, unlike last time, I wasn't able to find even a vague reference of this happening with purple gold. What I did find, though, were a lot of sources that mentioned a very similar problem that commonly happened with pure aluminum. I also found a really useful report that talked about this issue in detail, and they provided a photo
from Oak Ridge National
of what
Lab.
it could make the aluminum
I know a few
look
people
like.
that work there.
All of the dark spots were small holes, just like what I was seeing with the purple gold, and apparently, this was mostly just caused by moisture in the air. This is because when aluminum is molten, it's able to react with the moisture, which then causes it to form some of those crusty oxides like we saw before,
Sure.
as well as some hydrogen gas. I always kind of assumed that all of this hydrogen then kind of just floated away, but apparently, a lot of it actually gets dissolved into the molten aluminum. Then, as the aluminum
Interesting.
cools, the solubility of the hydrogen slowly decreases, and right around the time that the aluminum is solidifying, it all gets kicked out as a bunch of bubbles.
Hydrogen gas is actually something at extreme temperatures. I'm talking north of 2200 degrees Fahrenheit, well over 3 times hotter than the temperatures in a pressurized water reactor. That's when the hydrogen gas production occurs. That's with the zirconium, which has a way higher tolerance for temperature than aluminum, is used in the nuclear fuel cladding. It can have a reaction with water that can generate a lot of hydrogen gas, which is explosive in certain concentrations. And that's the main hazard that can cause explosions within. That's the main reason why the core cooling critical safety function for accident mitigation is to keep it well below that 2200 degrees. You enter the highest threshold for that when core exit thermocouples, which is as close as you can get to measure these sort of things, is at 1200. Because a calculation is done extrapolating outward from where the fuel cladding actually is versus where you can measure it. And basically your actions are to ensure all of your safety injection systems, your emergency core cooling systems are functioning properly. If they are, you'll never get to that point. So the only time I've seen that in a simulator scenario is when they break all of your independently separated systems just to make the scenario hard. The odds of such a thing happening are greater than 1 in a billion shot per year. What's interesting is when you manage risk in a nuclear plant, saying something's a 1 in a million chance is still unacceptable risk because we're talking about fuel damage. And keep in mind, I'm talking about fuel damage, the so-called meltdown event, not dosing the public, because you can have meltdowns without causing a radioactive release. We saw that in the 3 Mile Island. Hydrogen causing explosions, breaking the reactor coolant system. The containment buildings do have systems in place, such as hydrogen recombiners, and those recombiners use platinum or palladium as a catalyst to get hydrogen at high temperatures to recombine with oxygen to turn it back into water. And we didn't have this at the plant I worked at, but you can also use what are essentially spark plugs. So how do you prevent a bad hydrogen explosion, a really big one? Well, you can set off a bunch of little hydrogen explosions, because the big ones are the ones that could potentially cause damage to the reactor containment building, whereas it's designed to withstand a lot of small explosions. But yes, hydrogen rearing its ugly head again with metal casting, just like it does in nuclear power plants. Though it does different things.
What I thought was interesting, though, was that they also provided this photo, which is what it looks like if all of the hydrogen's removed before it solidifies. There's a pretty obvious difference, and all of those cavities are completely gone, and now it's just a nice and smooth piece of aluminum. After seeing this, I felt that it was pretty clear that this was almost the exact same issue that I was having, and this seemed to be confirmed when I looked back at some of my footage. More specifically, I looked back to when the bar was solidifying, and I was able to see what looked like bubbles popping on the surface. When I saw this, I felt that it was pretty clear that this was all just hydrogen gas getting kicked out as it solidified. The only thing that I thought was weird was that I was already using argon to block out all of the air, and therefore the moisture, and I wasn't entirely sure where this hydrogen was coming from. I mean, it was possible that it was from the short period of time that it sat there in open air before solidifying, but I really didn't feel like that was the case. Either way, though, if I wanted to make something that wasn't hideous, I was going to have to somehow get all of the hydrogen out of the aluminum, And there were apparently many different ways to do this.
It's interesting because he mentions the argon. That's also the same reason why it's used in welding applications.
So I decided to just try everything that I thought might work, and one method that I thought was really promising was to just include a bunch of table salt. However, again, most of the things that I tried totally failed, and after a week of frustration,
We used borax earlier.
I felt that I was left with only one real option.
Was the intent to use it as a flux material, so it just kind of forms this little molten layer that acts as just a blocker from oxidizing the actual gold aluminum?
For this one, I was going to have to try and bubble some argon gas through the molten purple gold, instead of just using it to protect it from air. This was actually something that I'd been kind of avoiding, because even though it sounded relatively simple, it was kind of tricky, and I wasn't going to be able to just lower in my stainless steel tube.
Yeah.
This is because at 1200 C, the aluminum was way too angry, and it would just dissolve it.
Angry.
And I saw this happen firsthand when it dissolved one of my steel spatulas. So I was going to have to swap out my tubing for one with a different material, and unfortunately, there weren't many other options. I couldn't just use other metals because they would also probably get dissolved. I couldn't use glass because it would melt, and I couldn't use graphite because, as far as I can tell, small graphite tubes don't exist. After thinking about it for a while, though,
Graphite's
I started
also
wondering if
risk.
something like fused quartz might work, and I remembered that I actually had a bunch of small tubes that I'd gotten for free. Just by looking at them, they appeared to be pretty much the same as normal glass, except unlike normal glass, they were made with nearly 100% silicon dioxide. This would make them significantly more resistant to high temperatures, and there should be almost no risk of it melting or cracking, and I really didn't see why it wouldn't work. I also had a lot of faith in fused quartz after I'd used some to burn diamonds.
I remember
and it
that
survived being red hot under a flow of pure oxygen. So I decided to give it a chance, and I was really excited to get started, but then I realized that I actually had no gold left. This is because in all of my random attempts, I had apparently used all 99.99 grams of it, and it was now just a bunch of random trash. This was kind of a huge pain, but I didn't really have a choice, and I just quickly redissolved it all in a bunch of acid, and I processed it in the same way as the original gold bar.
There we go, yeah, just like the
Then after
the
a
panning
couple
for
days
gold
of work,
stuff.
I had some nice and crispy gold powder, except when I weighed it, it was only 95 grams.
Ooh.
This meant that I'd somehow lost about 5 grams of gold along the way, and this made no sense to me because I'd been extremely careful, and I thought that I'd collected absolutely everything.
Well, he did so much, like cutting and sanding and smashing and all of that. It's hard to catch all of that, even if you happen to be using it on working on the same surface. Yeah, he did so much that I'm actually not surprised he didn't lose more of it. Just given what he's showed us in these steps thus far.
Either way, I could now finally test out my new method, so I went back to my furnace and I poured in all 95 grams of the gold that I just purified. This is because I didn't think that it could be done on a very small scale, and if I wanted to actually be able to bubble gas through it, I felt that I was going to need as much molten metal as possible. With all of the gold melted, I then carefully lowered in the quartz tube, and with it in place, I slowly opened the argon. Then on top of this, I dumped in the aluminum, which all quickly melted, and this time, I stirred it with a graphite rod. This was also what I should have been using from the beginning, because unlike my spatula, it wouldn't just dissolve, and when I eventually felt that it looked
Now, one thing about stirring stuff like this is, so I wouldn't know this from personal experience, but just based on how air and heat transfer work, you got to be careful with that. Because if you're a little too aggressive, you can potentially introduce air and other impurities just from the turbulence of stirring. So there's a trade-off between trying to achieve the homogeneity that you would get from stirring and actually introducing something to the system that you don't want.
good. I lowered in the quartz tube, and I slowly increased the gas flow. My goal was to get it to bubble as much as possible without splashing too much, and the idea here was that the
It's kind
argon
of a funny noise.
would carry the hydrogen out of the metal. To a certain degree, this would also help mix the gold and aluminum, and when I felt that it was going at a steady rate, I covered it with some insulation.
Cool.
I then had to leave it like this for a while to make sure that I got out as much of the hydrogen as possible, and based on what I read online, about 20 minutes seemed decent. So I basically just had to wait. Meantime, I went and got my mold, which was again, just a simple bar mold.
Gold bars.
This is because I had to make something that I could compare to the last one and to see if this
Apples to
process
apples.
had actually
sense.
made a difference. But anyway, at this point, it had been about 20 minutes, so I started blasting the mold with the torch. Then, when I eventually felt that it looked nice and hot, I quickly took apart the whole degassing setup, and going as fast as I could, I poured it all into the mold. After that, I waited for it to cool down, and when it got to around room temperature, I popped it out of the mold, and I started cleaning it up. Almost immediately, it was already pretty clear that there was a major improvement, and even after very little sanding, it looked like most of the cracks were gone.
Nice.
I would only really be able to know for sure once it was all nice and shiny though, so I just kept on going, and many horribly painful hours later, I annealed it, and this was what I eventually had.
Whoa.
Without even comparing it to the other bar, this one was clearly way better, and what I was extremely happy to see
That's beautiful.
was that it didn't seem to be riddled with a bunch of small holes. To actually know how much better it was though, I was going to have to pull up a photo of the old one, and the moment that I saw it, the difference genuinely surprised me.
Seems a little bigger too.
It was actually somehow even uglier than I remembered, and it was pretty undeniable that the degassing step had made a significant difference. I mean, if I really zoomed in, I could clearly see some very small holes, and it definitely wasn't perfect, but overall, I still thought that it was really nice, and I was very happy with how it turned out.
One other interesting thing about hydrogen is it can actually reach a point where it's too rich to burn. In air at normal atmospheric pressure, that's a concentration of 75%. The main generator at a nuclear power plant actually uses hydrogen. It's kept above 98% concentration, so well above any threshold where it'd be explosive. Now, you don't want any hydrogen leaks because it has several advantages, such as high thermal conductivity. It's important to have that in any sort of coolant, just in how efficiently it can transfer heat and cool off the generator. It's non-corrosive, at least to generator components. It's low windage. There's little losses caused by the friction of gas as the rotor moves through it for the generator, and that's just because hydrogen has very low density. So it'll ultimately make your generator more efficient, as well as keeping it cool. Disadvantage is you don't want a hydrogen leak, because again, hydrogen can be explosives. If you're between 4% and 75% in air, you don't want to have anything to do with hydrogen.
The only thing that was still kind of off was the color, and just like the other bar, it was definitely more on the pink side. However, as I mentioned a couple times earlier, it turned out that this was all just an annoying lighting issue. This was actually something that really messed with my head for a while, and it's honestly sad how long I spent staring at little pieces of metal and trying to compare their colors. What really settled things for me, though, was getting that pendant from Lenoir, which allowed me to compare my stuff to some professionally produced purple gold.
Wow.
I also started using a polarizer for my camera, which would let me remove some of the reflections, and suddenly, it was very clear that they were the same color.
Nice.
To me, this really showed that it was all just lighting, and I think that my bar is just a lot shinier or something, which makes it generally appear
surface
brighter.
treatments. That's
color aside, though.
Just for jewelry.
At this point, I finally had what I felt was a decent way to make the purple gold, and after months of going in circles, this was a huge relief. However, I of course wasn't quite done yet, and the last thing that I still had to do was make my ring, which was the entire reason why I started this project. The only concerning part was that I still wasn't entirely sure how to do this, and I was kind of worried that I'd end up in another horrible pit of trial and error. To try and avoid this, though,
I know how to make
I decided
material.
to go with the simplest method that I could think of, and the first thing that I did was buy a ring sizer from Amazon. I then tested a bunch of them to see which one fit my finger the best, and this was extremely important. This is because, as we saw before, the purple gold was completely non-malleable, and this meant that any cast that I made had to be almost perfectly pre-sized. With that being said, when I eventually found one that I thought fit, I was able to make a super basic 3D design, and now I just had to turn this into a mold.
That would be pretty annoying for actually making rings, because I know that's one of the most important things to get it, is to get your ring is getting the ring size just right. I mean, I know before I got married, I had no idea what my ring size was. And I actually wear the same ring that my dad did, and who is no longer with us. I wear the same ring to honor him, but he had way bigger fingers than me. I had to bring it down 2 sizes. So I can see that as a pretty serious drawback of rings, especially rings you want to pass on to not have that ability to resize them.
With normal gold, there are a few common ways to do this, like with lost PLA casting,
with a Z.
But I was worried that all of them would end up having issues with the purple gold. So instead, I decided the best idea was to just do it in a graphite mold, which I was now very familiar with, and I knew would probably work. The only tricky part was that I couldn't just buy a mold, and for it to perfectly fit my finger, it was gonna have to be custom made. In theory, I probably could have found someone online to do this for me, but instead I used this as an excuse to buy a CNC machine and to learn how to carve out my own graphite molds.
Nice.
This actually ended up being a lot of fun, even though it was sometimes a bit frustrating, and I can now make pretty much any graphite mold that I want. With that being said, for this project, all I had to do was make this super simple one, and with it now ready, I was finally able to try and make the ring.
That's fun.
So again, I just quickly repurified all of the gold that wasn't used to make my big bar, and I remelted half of it in the furnace. I did this so I'd be able to get at least 2 attempts, and I was just hoping that 30 grams of gold and about 7 grams of aluminum would give enough volume for the degassing. I then let it sit there, and after about 15 minutes, I started blasting the mold with a torch, and I was eventually ready to try and pour it. I was honestly really concerned that I would either completely miss or that the metal wouldn't flow through the entire thing. Yeah, that's hard to get it in there.
Whoa!
But it turned out to be totally fine. All I had to do now was wait for it to cool down, except this part I was actually more concerned about because I knew that this was going to cause it to shrink. This was also a huge issue because this meant that the inner side of the ring would start contracting while the outer side of it would stretch, and since the purple gold had no real malleability or ductility, this would almost definitely cause it to break. To try and avoid this, I'd purposely angled the inner edges of the mold, hoping that as it contracted, it might pop itself out without cracking. At the same time, I genuinely believed that there was a narrow window of time where it was possible to manually remove it, and I just kept trying to pry it out.
Oh no.
However, I apparently wasn't skilled enough, and it ended up just cracking itself in half.
No.
It just snapped. This was also really sad because the ring had actually molded super well, and now, unless I want to spend days repurifying everything again, I only had one last chance. So I just anxiously whipped together another batch, heated the mold red hot, and carefully poured everything in. This time, though, there somehow wasn't enough metal to fill the entire mold, and at first I was sad about this, but it actually turned out to be a good thing.
As it expands.
This is because it prevented the ring from fully connecting, so as it contracted, it didn't just squeeze down on the middle part and snap itself, and I was actually able to get it out of the mold.
It's one advantage.
Huh.
It's a one piece.
What I had now wasn't exactly what I was expecting, and it kind of looked like a failed attempt, but at the same time, I felt that this different shape was kind of cool, and I decided to just go with it.
There are rings that look
I
like
then spent
that.
the next couple of days sanding
There
and
are rings
grinding
that
it,
look like that.
and this time I also used a Dremel,
Yeah, there you
which
go.
made things a lot easier. The part that I actually had the most trouble with was just coming up with a design that I liked, and almost the entire time, I was really worried that it would turn out absolutely hideous. Eventually, though, I was able to make something that I felt I was happy with, so I polished it up as best I could and then annealed it, and this was the final result.
Wow.
It was honestly way nicer than I ever imagined it
cool.
would be, and I kind of found it hard to believe that I had actually done it. I finally had my ring that was made entirely out of purple gold, and it was probably one of the only ones in existence, and after months of work,
That's awesome.
I
How
think it
does it
was all
fit?
worth it. What was also nice was that it wasn't nearly as fragile as I thought it would be, and even though I'm not going to test it, I don't think it would break if I dropped it. I also
can
don't think
understand
that it
not
would
to.
be a problem to casually wear it, as long as I'm careful,
There you go.
and I would probably just have to avoid accidentally slamming
Index
it into
finger.
things. With all that being said, though, when I first started this project, I was honestly really concerned that it would just be
Does
a
it fit
total
on your ring
failure,
finger?
especially because of all of the things that I had read online. However, it turned out that purple gold wasn't nearly as bad to work with as I thought, and with just a relatively simple setup, I definitely think that it's possible to make some nice jewelry. I also think that there's still a lot of room for improvement on the method that I used, and I already have a
That's so
few
cool,
ideas
though.
that I want to test out. For example, something that I really want to try is just using higher purity argon, which has less moisture in it, and I want to try swapping my quartz tubes for something like alumina. I'm also kind of tempted to completely switch to a different degassing method like ultrasonic, and most importantly,
That's kind of cool.
I think there are definitely some better ways to cast and mold it. For now, though, I think I'm kind of tired of melting, casting, and grinding purple gold,
I can see
and
why.
instead I'm going to work on some more tasty projects, like turning air into alcohol.
That's hilarious.
Okay, so in the end, this was probably the most tedious and frustrating project that I ever worked on, and what made it even worse was that I somehow kept on losing gold. I honestly still have no idea where it went, because I was really careful with everything, and I'm kind of convinced that it just got evaporated or something with the aluminum.
Or grind it
Either
up.
way, though, I'm really happy that it's all finally done.
That was so cool just to see all the different processes that went into it. And again, just see someone kind of figure something out, something that isn't well known even by jewelry, metal casting, whatever subject matter experts that are out there, and show it to us on YouTube every step of the way. That is probably the thing I love the most about NileRed's channel, is how he just goes through all these steps, including the steps that didn't go so well. Thank you very much for watching. I'll see you next time.